Hi there, welcome to the RetroDesk. I'm Matt Heffernan. This is the second lesson of my newest tutorial series for people to learn programming using the Python language. This tutorial is for absolute beginners, no experience necessary. But if you haven't watched the first lesson, you'll want to stop right here and go watch that if you have never programmed before. In that first lesson, we learned the foundations of what programming is and how to use the Python language and tools like the Thani integrated development environment to write and run code. We made our first program using the print function and learned how to make text appear in the shell. We learned about variables and types, specifically numbers and strings, and we learned how to write our own function. We're still just starting out, so we'll review these concepts as we go. We saw how the print function outputs text to the shell, meaning that the string you pass to it will appear when the function is called. But programs don't have to just output text, they can input text as well, meaning you can type something in and the program will read it and do something with that input. Appropriately enough, Python has a built-in function called input to do just that. When you call input, it stops the program and waits for the user to type something. When the user hits the enter key, the function will return a string containing the text the user typed before hitting enter. So you can use the print function to prompt the user to type something, and then the input function to read it. Then you can take that string that input returns and use it for something else. The best way to see how that works is to write a quick program. Let's start writing our code here in the text editor of Thani. For our prompt, we'll have our program ask the user's name by simply printing, "What is your name?" Then we want the program to pause and show a cursor for the user to type their name. This is what the input function will do. But to get the text the user types, we'll need the return value of the input function, so we'll just call that name. And then equals input parens, which will make the name become a string variable. Now we can do all sorts of stuff with that string, but all we've learned so far is how to combine strings into longer strings and print them. So we'll do just that. We'll call the print function again, and this time pass it a string that states the obvious. Your name is space, and then we add the name that the user just typed. As we learned in the first lesson, this is called concatenation, and when you add strings together, they just make a longer string. Strings are just sequences of characters, so the concatenated string will have all the characters of the first string, then the characters of the second string right after them. Now that we have our program written, let's save it as input.py, and then we can run it right here in the Thani shell by clicking the Run button. As expected, we get the prompt text from the first line of our program, and then a cursor below it. Now we can type our name and hit enter, and there we go. Now we know our own name. So just printing input back to the user isn't very interesting. Usually a program will need to interpret the string that is returned by the input function. This is called parsing. In our program, we just expected the input to be a name, and we just printed out the whole thing as it was typed in. We didn't try to change the string in any way other than adding it to the end of another string. But what if we expected a number and not a name? The input function always returns a string. We would need to convert that string into a number if we needed to do any math with it. In our first lesson, we used the str function to convert a number to a string. Now we want to go the other way. If we expect a string to contain an integer value, that is just a whole number with no decimal point, we can use the int function. Like the str function, the int function will try to interpret whatever you pass into it as an integer and return it as an integer number. A good way to see how this works is by using the shell. If we just call the input function in the shell, it will give us the cursor. Then we type something in and hit enter. Then the shell prints out the return value of the function call, which is the string we typed. We can see that it's a string because the shell puts it in quotes. So even if we call input again, and this time we type a number, the return value is still a string in quotes. That means Python doesn't interpret it as a number, just a sequence of characters that happen to be number characters. So let's call input one more time. But this time we'll assign the return value to a variable, and we'll call it age. So age equals input, parens, and hit enter. Now at the prompt, we'll type another number. Now we don't see it printed back to us as a string because that string has been assigned to the variable we call age. So if we type age and hit enter, the shell will show us the value, which is that same number we typed. Now if we wanted to just add 1 to age to celebrate an imaginary birthday, we can try typing age plus 1 and hitting enter. Just like in our last lesson, we get a type error telling us we can't concatenate a string with an integer. We need to either do a string concatenation like we did earlier with the name, or do integer math, which is our intention now. So if we call the int function and pass in the age variable, we now get a number and not a string. We can see it's a number because it doesn't have quotes around it anymore. So now let's do the actual math and type in int age plus 1. And finally, Python is letting us celebrate our birthday. Let's go back to our program and apply what we've learned. Let's print out another prompt and ask another personal question. We'll do print what is your age? And then on the next line, get the user to type an answer in, this time assigning it to a variable named age, just like we did in the shell. So again, we do age equals input, parens, and this will give us a string variable containing the user's age after they type it in and hit enter. So now we want to do some math. So we define another variable called nextAge and assign that the integer value of age plus 1, just like we did earlier in the shell, but now the result will be in a variable. Unlike the age variable, the nextAge variable is an integer, not a string, because we assigned it an integer expression. That means when we convert a string to an integer and add it to another integer, that will produce yet another integer. So if we want to print nextAge out to the user, we'll need to convert it to a string. So our last line will be print you will be space plus string of next age plus space on your next birthday. And close the quote, close the paren. Here we can see that we are concatenating 3 strings together, the first part of the message, then the new age we calculated converted to a string, and then another string to complete the message. We can build strings of any length like this, piecing together as many fragments as we want, not just 2 or 3. So now let's run it. Like before, we type in our name and get that repeated back to us, but now a new prompt under that to enter our age. So we do that and hit enter. And now we get our new message. Note that we have spaces around the new age in the message. That's because we made sure to leave a trailing space after the first string fragment and a leading space before the third fragment when we called print that last time. Python won't know to put spaces like that in automatically. And maybe you don't want them in some cases. So it's up to you to format your strings in the way you want them. So now we have added parsing to our program, which means we are processing a string to get new values out of it. That may just be a single integer, like in our program's case, but it may be more complex and have multiple values in a single string that need to be pulled out. We'll be going over more of that in later episodes. One big thing to understand is that parsing depends on the string being in the correct format for the value you are expecting to get. In this case, if the user typed something that wasn't an integer, we'd have a problem. Let's go back and run this program again. Okay, we'll type another name in. Because we aren't doing any parsing of the name, it can contain anything, so we'll just put garbage in by wiping our hand across the keyboard and then hitting enter. No problem there, our program just prints that garbage back to us. Now when we get prompted for an age, let's have a little brain fart and put in our name. Ooh, Python didn't like that. Our program crashed on that input. Python says we had an invalid literal for the int function. Apparently Matt isn't a number. So how do we prevent this from happening? We're going to need to take a deeper look at how Python works. Python is what's called an object-oriented language, meaning that everything in the program is an object. But what does that mean? We've dealt with two types so far, strings and integers, and used built-in Python functions to work with them. But strings and integers are really objects of classes called str and int. But what's a class? Just like in the real world, a class in Python is a general type of object that tells us what we can expect of it. Let's get away from integers and strings and talk about something a little more tangible, but still simple. Consider a square. The name square is a class of shape, and it tells us certain things to expect about that shape, like that it has 4 equal sides and 4 equal internal angles. What can vary about squares are the lengths of the sides and maybe other things like their color. So square is the name of the class, and then individual squares can have different sizes and colors. These are objects of the square class, and we could give them creative names like square 1 and square 2. So square 1 has sides that are 3 units long and its color is red, and square 2 has sides that are 2 units long and its color is blue. Here we have defined two square objects and given them the expected attributes of side length and color. So besides attributes, objects can also have methods that use these attributes to do something. If we want to find the area of a square, we need to multiply the side length with itself. That's why it's called squaring. So the square class can have the attribute side length and a method called area that would calculate the square's area and return it. Since that method is the same for any square, it can be defined once for the square class and get called for any square object. In Python, we access attributes and methods for objects in the same way, by having a dot after the name of the object variable, followed by the name of the attribute or the method. Attributes themselves are little objects in their own right that are part of the larger object. Methods, however, are functions, so they need to be called like functions with parentheses and possibly arguments. For the area method, we have all we need in the side length attribute, so it doesn't need any arguments. It should just return the value of side length times side length. In a future lesson, we'll learn how to define our classes like this, but for now, we're just going to learn how to use the built-in classes we've already learned about. First, we're going to look more closely at the string class, which is called str. That's why the built-in function str is called that. And it's really not just a function technically. I know I've called it that because it works exactly like one, except that it is really a constructor method. So what's a constructor? That's a method that you can use to create an object of a class. Now, strings are a special built-in type for Python, so we can just put a literal string in quotes and assign it to a variable, and that will create a new string. But the str function is doing the same thing, except that you can pass it something that isn't necessarily a string and get a new string based on that argument. Once you have a string object, you can call a whole set of methods on it. One of those is called isdigit, which returns a Boolean value. But what's a Boolean value? That just means it is true or false. So if a string has only digits in it, then isdigit will return true. If it contains any characters that aren't digits, then it will return false. Let's give this a try in the shell. Okay, let's define the age variable to be a new string. We'll use the string constructor and pass in an integer, and that should return a string with digits for that number in a string and nothing else. So if we just type age at the next prompt, we'll see the value, which is a string with just digits in it. We can confirm this by calling the isdigit method on it, which we call by typing age.isdigit parens and hit enter. And then the shell shows us the return value true with a capital T and no quotes. That's how we know this is a Boolean value and not just a string that says true. Now let's reassign age to be something else, like the name we put in the last time we ran our program. Now we can see that isdigit returns false, again with no quotes. This is a Boolean return value indicating that this string doesn't contain only digits. We have letters instead. In Python, we can also have an empty string, which would just be a pair of quotes with nothing between them. So if age is an empty string, calling isdigit will return false again because it doesn't contain any digits. For it to return true, the string needs to contain at least one digit and nothing other than digits. So if a string is only digits, then we can parse it into an integer without seeing that error. But how do we avoid that error? If we want to have our program do something different based on what's going on while it's running, we can use what's called an if statement. Python sees if as a special keyword that needs to be followed by a Boolean expression. But what's a Boolean expression? That's just a statement that can be true or false. Like 3 is greater than 2 is a true statement. So if we say if 3 is greater than 2, we know that whatever follows will happen. In Python, we need to put a colon after the Boolean expression, and then the next line needs to be indented, just like when we define a function. But now we aren't writing a function, just some code that will only be run when the condition of the if statement is true. So we could print something like, yes, 3 is greater than 2, and know that we are going to see it happen when we run the code. But usually this expression is going to have variables that we don't know the value of, like something we got from user input. So we could say there's a number variable named x, and we could then replace 3 with x in the code, and now we have an if statement that may or may not print the message based on the value of x. If x is 4, then we would see the message. If x is 1, we will not. So we want to do the same thing in our code, except instead of a numerical comparison, we're going to call the isdigit method that returns a Boolean value. So we don't need to compare it to anything. We can make the method call the whole condition and then a colon and put our message inside that if statement where we know that the age is entered is a valid integer and not something crazy like a name, and we can avoid the error. Let's try that now. So before we try to parse age into an integer, let's start our if statement and use age_isdigit as the condition and finish with a colon. Now we want the next 2 lines to be indented so they only get called when isdigit returns true, and that should do it. Let's try running again. First we play nice with the program and type our name in first, and then a real age. And we get our next age like we expected. Now let's go off the rails and put in garbage. Okay, garbage for the name, and garbage for the age where we have a bunch of non-digits, and then we don't get the last message, but we don't get that error either, and our program doesn't crash. That's a big improvement, but we still leave the user without any explanation of what happened. So we should really print something when the age isn't a valid number. But how can we do that? The if keyword has a little friend in Python named else. After an if statement, we can immediately follow it with an else statement that can be run if the if condition was false. Let's say x is not greater than 2. What then? If we place else at the same indentation as if, followed by a colon, we can start another block of code to be run when x is not greater than 2. That code will need to be indented just like the code under the if statement. And here we can print the insightful message x is not greater than 2. Now when this code is run, depending on the value of x, we will see one of these messages printed, but never both. Let's try adding an else statement to our program in Thani. On the next line, we go back to the far left and type else directly under if and then a colon. Hitting enter will make Thani automatically indent for us, as the colon means we're starting a new block of code and it should be indented. Now we just want to print our own error message telling the user what happened. We can even be polite and say sorry, and then have the original string they typed in for age, and then space is not a whole number. And then the program is done and the user can at least see why they didn't get their expected response. Let's try running it again. We'll do another happy path and type in a name and then a valid age. And now we see the birthday message. Okay, let's go back and put in garbage. Your name's whatever, and our age is just some random characters. And now we see that our random string is not a whole number. So now we are getting useful information each time we run the program and nothing is crashing. Let's take a moment and review what we've learned so far this lesson. We've learned about the built-in function input and how we can use it to let the user type in something while the program is running. We learned how to parse a string by using the int function. We also learned that int and str are really built-in classes, and the functions with those names are really constructor methods to create new integer and string objects. We also learned that classes can have attributes and methods that can be used with objects of those classes, like the isdigit method can be called on a string to see if it just contains number characters. We learned that a Boolean value is either true or false, and that calling isdigit on a string will give us a Boolean return value. We learned that we can use a Boolean value or an expression for the condition of an if statement, and that an else statement can be used to define an alternative block of code to run when the condition of the if statement is false. Yep, that's a lot, but each thing is a pretty simple concept, and we're going to get deeper on them as we go through this tutorial in later episodes. If you're feeling a bit lost, you can go back to the chapter of the video you want to see again, or maybe even go back to a chapter of the last video and go over that again. Remember, you are in control of the pace you are learning. So far we have learned about 3 built-in types in Python: strings, integers, and Boolean values. We also learned that strings are object of the str class, and integers are objects of the int class. And we've used the constructors of both of them now to convert values between these two types. Boolean values are actually objects of the bool class, and it also has a constructor method. You can pass it any value, and Python will say whether it can be interpreted as true or false. It's not always obvious what is true or false, so a good way to test that is in the shell. Okay, if we just call the bool constructor without any arguments, we get a return value of false. Because as far as Python is concerned, nothing isn't anything, so it has a Boolean value of false. This may seem strange now, but this is a very valuable part of the language that we'll make use of another time. Let's try passing in an integer into bool, like 42. Hey, now we get a value of true. Maybe 42 is the answer to everything. Just to make sure, let's try another number. Okay, so 52 is true as well. What about 0? 0 is nothing, so the Boolean value of 0 is false. Integers can be negative, so is less than nothing still nothing? Nope, only 0 is truly nothing, so the only integer that can have a false Boolean value is 0. This is also very useful in Python, as we will see in the near future. But what about strings? We use the int constructor to convert strings into integers if they are made of digits. What about the string true? Yep, that's true as we expected. So false must be false, right? No. The string false isn't nothing. It has 5 characters in it, which is something. What if we pass it an empty string, just a pair of quotes with nothing in between? Yes. An empty string is nothing, so it is false. The only way to pass something into the bool constructor and get false is to pass the literal Boolean value false, with a capital F and no quotes. And we can pass in a literal true and get true, note again, a capital T and no quotes. You could also pass in a Boolean expression, like 2 is greater than 3. And yes, it's false. But of course, we don't need to pass Boolean values and expressions into the bool constructor. They are already bools. So we can just type them into the shell prompt, like false. Or 2 is greater than 3, which is also false. Or 3 is greater than 2, which of course is true. So we can play around with all of these types by using their constructors to make new objects. But what if we just want to know what type of object we are dealing with? For that, Python has a built-in function called type, and we can pass it any value or variable name or expression and get what the type of it is, what class it belongs to. So the type of true is Boolean, so it is an object of the bool class. Same goes for a Boolean expression. The type of 3 is greater than 2 is also a bool. But the type of just 3 is int. If we put quotes around 3, it's now a string, an object of the str class. But what's the type of 3.2? A new built-in class, float. So what does that mean? So a float is a floating point number. This is a different way for computers to deal with numbers when they aren't strictly integers. A float can have any real numeric value, and the decimal point can float around to any position. We could have a really small number like 0.0001, or a really big number like 6.02 times 10 to the 23rd power. In Python, we can write this as 6.02 E23, where the E stands for exponent, just like it would on most calculators. Well, let's try this back in the shell. Okay, let's type in 6.02 E23 and hit enter. We see the value printed back to us, but now with a plus between the e and the exponent value of 23. This is Python's standard for exponents, but you can always leave out the sign and Python will assume it's a positive exponent. We can put in a negative exponent like 1e minus 4, and rather than print back what we wrote, Python just applies the exponent as the number can be expressed with just a few digits. If we made a much tinier number, like 1e minus 10, we can see that Python would rather not print out all those zeros, so it keeps the number in exponential form. Just like how a calculator usually has a maximum number of digits it will display, so does the Python shell, but it's a little less consistent. You can try different big and little numbers and see whether Python prints them as a plain decimal value or as an exponential value. Also, floating point numbers have a limit to their precision. You can't have pi with infinite digits. As we can see here, if we type in pi to 20 places, Python will cut it off at 15 places. But 15 places is going to be good enough for most things, so that's what we can use for floating point math in Python and still be okay. So these are all the primitive types for Python. And really, strings aren't that primitive, as they have a sequence of characters and not just a single value. Other built-in types in Python include list and set and other ways of dealing with multiple values as a single object. We'll get into each of these eventually, but for now, we have come to the end of this lesson. I want to thank you for continuing to watch this series, and I can't wait for you to see the next lesson. If you aren't already subscribed to my channel, make sure you do that now and click the bell to be notified when the next video comes out. If you want to support my channel more directly, you could become a member here on YouTube or join our Patreon community, like the people you see here. Members and patrons get to see all my videos before they are released ad-free, along with other nice little perks. Thanks for watching, and I'll see you again soon. Bye-bye.